today. I would like first, maybe I'll introduce myself. I'm Sonia Lioré. I'm the CEO from the French Wind Energy Association. And I will try to lead as good as possible this panel on wind turbines and new technologies this afternoon. So let me introduce you the participants of the panel. So Arif Gunyar, who is Regional Sales Manager at Enercon. Paula Garcia Los Arcos, who is Europe South Sales Manager at Gamesa. Andreas von Bobart, who is General Manager Renewable Energy Germany at General Electric. And Andreas Beyer, who is Senior Product Manager at Nordex. A few introduction. We will address one topic after the other. So the best would be I will open the floor for questions after each subject. So please feel free to ask whatever question cross your mind related to the topic. And the panelists were very keen of having difficult and challenging questions. So please feel free. Okay. And since it's 2 o'clock in the afternoon and everybody feels a bit sleepy, I would propose that we start with, let's say, the most difficult question for wind turbine and new technology. What is the evolution? So my first question would be, how did the cost evolve for the last 5 years for your company? And what do you expect for the next 10 years? Maybe Andreas Beyer wants to take the first answer.
Thank you. Thank you very much, Sonia. And thank you very much for your participation at this panel. Very exciting topics today. I'm representing Nordex here, and Nordex is celebrating the 30th anniversary this year and looks back at 3 decades of being competent partner in wind. In Turkey, we have a full organization since 2009. Our first turbines have been installed in 2007. Looking at the levelized cost of energy, that represents the efficiency of our turbines. We have a decrease in levelized cost of energy from the very first wind turbines that have been installed in Turkey, that were wind parks near Izmir with an N90 2,500 megawatt at this time, towards the most recent project that we will install in 2015 that comprises of 12 N117 3,000 kilowatt turbines. The levelized cost of energy has been developed from the first wind parks towards the most recent models by 15% in decrease of levelized cost of energy. A second figure I want to mention is concerning the most popular Nordex model sold in 2013 in Turkey. That is the N100 2,500 kilowatts, towards the most recent low wind speed turbine that Nordex is marketing and selling in the market, the N131 3000, will give our customers a decrease in levelized cost of energy for particular low wind sites of more than 24%. So this characterizes pretty good that we are on a good way to have a good contribution into the Turkish market to sell energy efficient, green energy turbines, looking back into many years of being present here in Turkey with a full organization.
Okay. So after my colleague has looked into the past, I want to probably talk about what our expectation is in the future. So we've heard from Andreas that levelized cost of energy went down by about 15% over the last few years, and I guess most of the manufacturers have seen the same trend. If we actually look at cost of energy, not only in Turkey but in various countries, there's a broad range. A good and large wind farm in a high wind speed location comes down to 40 euros per megawatt hour, while smaller wind farms in low wind speed sites, and depending on the country and the feed-in tariff, go up to 100 euros per megawatt hour, and that's also confirmed by independent studies. And our expectation is that this bandwidth will narrow, and within the next say 5 to 10 years, we would see another 10% decrease at the lower end. So the very competitive sites will not see a very big decrease anymore, but the 100 euros per megawatt hour projects are not going to survive. So we would expect another 20% decrease at the upper edge of the bandwidth for LCOE. So that's our best guess looking into the future. And if you look at how this has to be achieved, it's basically by product innovation. So most of the companies here on stage are technology driven, and therefore rotor sizes, hub heights, capacity factors are basically the key drivers in that reduction.
So, well, thank you first of all for inviting Gamesa to this roundtable. Onshore wind energy is very competitive right now, most competitive than ever. That's a fact. I think cost of wind turbines will be reduced in the following years, probably in not such a relevant way that it was in the past. Take into account that 7 years ago, wind turbines, it was a demand market, not an offer market. And second, it was some prices, commodity prices, I'm talking about more steel and copper, that in the years 2007 and to 2009, they were extremely high. So the reduction on the cost of wind turbine has been due to that, but of course, wind turbine manufacturers, we are still looking for more and more competitive wind turbines. And why is it? Basically because financial support, talking about capital subsidies or energy premium fees, will tend to disappear. So wind turbines should compete with conventional power plant, and that's where the wind turbine manufacturers we are working on. That's the way. The reduce of the cost of energy is key, of course. Wind turbines are key, but we need to take into account the other factors which are very, very relevant. Maybe they don't have the height of the wind turbines, but let's talk about maintenance strategies. Maintenance should trend to reduce the prices. At the end, cost of energy is a mix of CapEx and OpEx. Of course, let's say balance of plant. We should go through reduction on the solutions that, together with the developer, we have, and other point, let's say other items that should be also taken into account, like financing that we are seeing here in Turkey. That financial institutions, they are going to lower rates right now. Insurance companies that should not only should focus only on the sector and not in the market also. So this combination of parameters will decrease the leverage cost of energy at the end.
Yeah. Please go ahead. Then you'll get a very difficult question, please.
Thank you very much, Sonia. Yeah, I would like to also give some figures from Enercon side. I'm representative of Enercon, especially for the region of Turkey and Central Asia, and mainly Kazakhstan. And I would like to give some figures from Enercon generally. So from today, we have more than 37 gigawatts installed worldwide, and the market share worldwide is also almost the same as last year, and means we will be also in the third, fourth place worldwide, I think, and in European-wide, I assume that we will also be market leader, and we are just expecting the new numbers from European Wind Energy Association. And in Turkey, we have already received more than 1,000 megawatt and more than 150 turbines. And the market share, according to market share, also we are the market leader in Turkey. And the Enercon is special for that we are producing the whole turbine, mostly 90% of the whole turbine in our own factories. So I'm a little bit agree with my colleagues, but on the other side, I think the turbines getting bigger and the production costs are increasing at the end, and also because the sizes of the turbines are bigger and the project costs like crane costs, transportation costs, they are not decreasing. But at the end, when I see the Bloomberg analysis, so in 2008 per megawatt it was 1.2 million, or let's say 1.2 million euro per megawatt. That was the price of 2008, generally worldwide, according to Bloomberg. And now it's again roughly 1 million per megawatt, what I see. And we got some decreases generally on the market after the global crisis, financial crisis. I agree, but anyway, the prices are not really decreased according to turbine sizes what we have on the market now. Thank you.
Okay. Thank you. No, I'll ask one question. Please feel free to take the mic to answer. So we heard about, I mean, okay, in terms of figures, between 10–20% decrease, and in terms of drivers of cost reduction, first, definitely this technology improvement, then the size of the wind farms, then also, let's call it non-technological evolution like maintenance. And I would ask also, I think maybe there's two other elements, and I would like you to tell me first what is, in your opinion, the most important drivers. I would say definitely it's competition between you, which is normally a big driver of competition, of cost reduction. Also, what will be, let's say, the pressure that the Chinese manufacturers will soon put on the market, and at what time, you know, at what time slot will you see this competition coming? And then on the other side, more and more markets are getting into local content, and this is more an aspect for cost increase. And how does your company deal with that? So, with the first volunteer, Mr. Beyer.
So maybe I can start, and I'm sorry. Maybe I can start answering some of the questions. Better? Better. So Nordics basically invested into Turkey not only by establishing a full organization to support the project management, to support micrositing, to support sales engineering, sales, and the whole bandwidth of a full supporting organization for the Turkish market, but also is able to produce local blades and towers, like others as well. On the blade side, we have the opportunity to support two basic models in our portfolio that covers most of the wind regime in Turkey. That is the N117 2.4 kilowatt. That is a closer? Still closer, okay. So we have a low wind side model, the N117 2.4 megawatt, and as well as the N117 3.0 megawatt. These two models are pretty much covering the whole Turkish market in terms of the specific wind regime. The blades are manufactured locally, and so we are able to increase the feed-in tariff that our customers will be getting for each kilowatt hour that's been produced locally. From the driver side, on the efficiency, I think Mr. Bubert already explained that technology is a key. Technology in terms of the configuration of the turbines that makes the turbine much more efficient. That is down to, for our perspective, two key performance parameters. That is, for instance, the specific rating, that is the watt per square meter, as well as if you go down to the levelized cost of energy towards the capacity factor. The capacity factor, which is defined by the actual generated power over a certain time of period, divided by the maximum power that can be produced. And this is a driving factor for a definition of a very efficient wind turbine, specifically for moderate and low wind sites. Needless to say that in the Nordics portfolio we have the best fit for these two parameters. In terms of cost down, yes, this is a lever as well for lowering the levelized cost of energy. A little less than the efficiency. What we believe that you cannot decrease the cost as much as you can increase the efficiency by applying modern or state-of-the-art technology.
Yeah. Then we stick to the same sequence. So first of all, the question about the competition, particularly from Asia. I've been on a similar panel about 12 years ago and heard the same question. And my answer 12 years ago was, I don't see them coming anytime soon. That has probably changed a little bit. So they might attempt to get into the export, and we see signs here and there that competition from Asia is trying to enter into these markets. But if you look at what we discussed on the previous question, cost of energy, that's part of the second answer regarding the drivers. It's cost of energy, it's innovation, and it's quality, life cycle costs. So I think our customers are looking at both things, capital investment costs and O&M costs. And I think our aim and our common game, although we are competitors, is to lower LCOE. And in that, I think we are still a little bit ahead of outside competition. So my answer is probably not anytime soon, but I don't see them coming in the next few years. Second aspect of that is that the competition is tough. The market isn't really growing on a global basis, so the established players try to do whatever they can. We do the same. New products are basically developed every 2 years, every 3 years at least. Service products will play a more important role. And I think that the established players are still way ahead of newcomers in the regions. And that also fits in line with what the governments are trying to achieve when they talk about localization. Most of us as manufacturers have made more or less good or bad experience with localization. So everybody is nowadays looking for a sustainable, stable market. Turkey is one of them. At least we see Turkey as a sustainable and stable big market. So there's a good chance that manufacturers are going to increase localization. Nordex does it, as we heard, we do the same, and I'm sure my colleagues will give a similar statement, and that increases the hurdle for new entrants because it's a big investment in a competitive environment. So we want to make sure that we are here. Also with a good organization, we've started localization, and that increases the hurdle for anybody else who wants to enter at a later stage.
I fully subscribe regarding ASEAN manufacturers, your point of view. Yeah, at the end, what we said before, cost of energy is a mix of both CapEx and OpEx. So, yeah, we are still a step ahead on that part. So, in any case, I would like to add one comment regarding local manufacturing. So, my colleagues here, Enercon in particular, they are manufacturing blades since 2002. So, localization of equipment manufacturing in the country is very, very important. But there is a break-even point. We need to take into consideration what we have seen in other countries, where the local content increase more and more, and at the end is penalized by the cost of energy. So I think that Turkey today is in the balance, but we do not forget the rest of the mistakes that other countries have done in the past, and that at the end have penalized the cost of energy of the country.
Yeah, Paulo, you have already mentioned what you want to say, but yeah.
We start with you next time.
Yeah, about the competition. Competition is good and it makes you alive. But let me, because of the local production, or about, again, Enercon is a slogan of energy for the world. And this is not a slogan only, it's just also the philosophy, what we are living. We are producing worldwide in 8 countries with more than 40 factories and on 883,000 square meters, our turbine. In Germany, in Turkey, in France, in Austria, in Canada, in Brazil, in Portugal, and in Sweden. So, which means we are bringing the energy in this country which is needed. And we are bringing also our production also in these countries to give work and to get employees locally. And this is what we have did also in Turkey as an example. In 2002, as Paulo already said, we have started at first in Turkey with the production. And just for you as information, in 2002 we got no renewable energy law in Turkey. It's a big trust. And also in some countries like Portugal, Canada or Brazil, also we have started very early to produce there. And okay, this is our advantage. We are producing in our own factories so that we can decide very fast to produce in this country. And since 2009 we are producing also the concrete tower segments in Turkey as well. And also the local, beside of the local production, is also the local employees like service or installation teams is also very important, so that we have more than 700 people in Turkey especially as direct employees of Enercon. And also in this sector of service company, Enercon has started with as first company in wind energy sector and so as a service company in 1999. And we have installed the first turbines in Turkey in 1998. And so we have installed the first licensed project in Turkey. So it's not only to sell the turbines and to deliver the turbines to the countries. It's our philosophy is also to bring together with our turbines to try to produce all the components locally and to try to find the engineers, the technicians also locally. And this is also very important for the acceptance, for the local acceptance. And also is good for this country that they can get the additional what wind energy or renewable energy brings. I mean, it's not only the energy which it's not costing due to resources, it's also bringing employment and also the whole academical, like engineers and technicians, they can find jobs, and this is very important. And so for that we are staying behind of this philosophy.
But does this philosophy of having a lot of production in country has important impact on the cost?
Yes. You are decreasing also the transportation cost, of course, because if you are producing locally, it makes sense. Yeah. But of course, what my colleague from GE says is sustainability is very important for this country and for this market, because of course we are not producing only for this country then. Like also in South America, it's not only for Brazil, it's also for neighbor countries like Argentina, Uruguay, etc., so on, where we are also be present. But it makes sense to bring it local, and also it's decrease the cost.
Okay, thank you. Maybe I will take some questions from the floor. Just let me, because I'm really always a bit tricky. Please, if you ask a question, introduce yourself first. If you ask a question to one particular person in the panel, please say it. And we'll have different session for question. So please focus your question on cost evolution. And if you're very nasty, maybe on pricing policy, but please focus on these two subjects. We'll have other subjects afterwards. So, any question? There's so many people sleeping. One question. There's one question here. If you think there's a microphone coming, it's at the first row.
My name is Alpa Sevinc. I'm from the Fraunhofer Institute for Wind Energy Systems. So first of all, I would like to thank you for the discussion. My question regarding the companies and the manufacturers right now is the difference of the technologies. So what I currently see is it's European technology distributed in Turkey. And what's the difference from the country? How is the competition between the technologies in Germany, for example, and the one in Turkey? Is it more low wind speed turbines? Is it high wind speed turbines? Or what's the difference of the blade design? Are there going to be any change, or is it going to change? Sorry, is it going to stay like the one in Germany, for example, or all over Europe?
Is there any other question before we go to the answer? I don't see any. So you have. So you got the question. I mean, do you is there the same technology, or do you adapt the technology according to the market and the market needs? I mean, if any of you want to take this question.
I do not manufacture in Germany, sorry, but I do in Spain, I do in US, in Mexico, in Brazil, in China and India, but could be an example. Yes, market condition, yes, they change the type of wind turbine, but not the technology, but more the rotor side in our case, okay? We have two platforms. We have what we call platform 2.0, 2.5, and we have different rotor sizes. So, for instance, in Mexico, where it's pure class A, 1A, so we have the rotor diameter which is between 80 and 90 for this platform 2.0, 2.5. In case of Turkey, we see class 2, class 3, so we see that is more feasible to go through larger rotor size, which is 114 in our case. So depends on the market, yes, but in our case we have a global industrialization plan. So we manufacture some parts in India for selling in Europe, we manufacture in Spain to sell in Uruguay, we manufacture in Mexico to sell it in Philippines. So it's a global logistical in our case. I don't know if this answer is enough for you. German manufacturers, because I think the question was for you.
Yeah, I mean, we have serial production. I mean, it's also given also on with Nordex or GE, I think with you too. And so that's why it's a question of the portfolio, what you have. And we have a portfolio in 4 platforms, like under 1 megawatt, means with 800 and 900 kilowatt rated power. And we have the platform with 2 to 3 megawatts, which begins with E70 to E115. And we have the new 4 megawatt platform with EP4, E126, and it's coming also the next turbine types in 4 megawatt platform. And we have also the E126 with 7.58 megawatt rated power. It's one of the biggest onshore turbine worldwide. So it's if you have such of this big portfolio, you can go in every country and offer all the turbines in accordance with the investors' expectations. Means also it's a geographical issue. So Germany, northern of Germany is very flat, and the wind shear is positive, or actually it's good. Means if you go higher with your turbine, means if you have very high hub heights, so you can get more yield. But Turkey is totally different. We have a lot of hills, so it means you don't need such of big towers. It's also enough if you have 80, 90 meters. There's of course, some places you can also get bigger hub heights, but it depends on. So accordingly, we have also a big portfolio of the tower hub heights and tower types, from steel tower to concrete tower to hybrid tower, so that we can offer to our customers worldwide, for each region, for each geographical circumstances, so that we can offer these turbines everywhere.
Okay, thank you. Maybe we can switch to another more technical subject now. We have seen in the last, from the first turbines until now, that the size of the turbine increased a lot and the power of each turbine increased a lot. Will this continue? Will we reach whatever boundary, maybe because of civil aviation, for example, in terms of height of the turbines? What are your expectations, and what is the new development, technological development you see in the near future? We can change the order if you want. Let's start with the only other woman of the panel.
Shall I start? Okay. So, in terms of configuration or definition of the perfect wind turbine, I would say usually the sky is the limit. However, we have limits in each country in terms of tip height restrictions, but also then it comes really down to the two parameters that I mentioned earlier on, the efficiency of the turbine. So it's basically, if you compare it with, broadly saying, if you drive a Ferrari, it's great to be on a German Autobahn, but it's not so great if you stick to city limits. So it's always the balance of how much material, so to speak, you put into your power plant in order to get the best return. Today we are on a point where we are talking about rotor sizes of 130, 140, 160 meter offshore, onshore, which can be coped also and balanced with the power generator to come to a specific rating that is in favor to define a very good, efficient turbine. This will increase, I would say, moderately as the regulation will develop as well. In Germany, we see, for instance, a long time we had a tip limitation of 200 meter. Now we see projects that go 200, 220, 230, even above that is under discussion. So in the whole configuration of possible hub height, rotor diameter, and efficiency defined in that combination with rotor diameter and rated power will define the best and the lowest levelized cost of energy. And this is all fueled and defined and pushed by new technologies like, for instance, a great push that was taking place within Nordics was the introduction of carbon fiber materials within their rotor blades, which enabled a much larger rotor span on a moderate and cost-efficient platform.
same sequence again. I think the question comes back to what Alpa actually asked. We are not going to see technology changes unless there is a significant change in the cost of energy. So if you want to have a major technology change in rated power or any component, split blades or whatever, you will always have to ask yourself the question, is it going to have a significant impact on the cost of energy? Otherwise, there won't be a change. And that's also what we think is an answer to your question. We don't see a big increase in the rated power of turbines, at least for onshore in the near future. Andreas already mentioned part of the reasons. Another reason is the logistics cost. If you look at the largest model we sell, that's a 120-meter rotor, 2.75 megawatts at, well, in Turkey the hub height restrictions are lower, but in Germany we sell it at a 139-meter tower. And the logistics costs have become a significant portion of the overall capital investment. And I think that's another driver why we think midterm and long term the average turbine power will be at about 3 megawatt level, give or take a little bit. Slightly different in offshore, although we don't do offshore. There I think the drivers are different, so we see a larger potential for increases of the rated power for offshore.
Yes, more or less. Gamesa has the same. We see that today at the end, which is the key, is the mathematically speaking, is efficiency is related to the power divided by the square meter, the swept area. The lower this ratio is, the more efficient the wind turbine is. So we see that in this case, people are looking for efficiency of the wind turbine, so they will stick between the range of 2.5, 3.5 megawatts. That's the mainstream and has been the past, and we foreseen this nominal power in the future. However, as Gamesa, we have wind turbines since 2009, which is 5.0 megawatts. And we see that this kind of wind turbines, they have also a niche. And this kind of niche is when you have a line limitation or when your net present value is, let's say, prevails over your interest rate or return. So, of course, there will be some solutions, or this solution is for this kind of problematics. But what we see, as my colleague says, is there is the mainstream between 2.5 up to 3.5 will prevail in the next future.
Yeah, to your question, Sonia. Yeah, if I don't know which way we will go in future. I mean, when I see the last 5 years, all of manufacturers, we are announcing every year mostly new turbine type. It's crazy. It's actually all the investors actually they are expecting now every year new turbine type. But this is not the right way, I think, because we have to be also reliable for the market. And of course, we are working on the new technologies and bigger turbines, etc., so on. But it should be also reliable. That's why, okay, we are trying our limits with physics, but as my colleague from GE said, so logistics also is one of the questions. Okay, what can we do about cranes? Transportation could be also problematic. But as Enercon, we have tried to solve this problem, or try to solve with divided blades, like with E115 or EP4, E126, that we have two blade parts, inner part and outer part, so that we are installing the blades on the side. So that's why the investors, they don't need to open a lot of access roads or permissions are not more needed a lot, but anyway the cranes for this size, for this weight has to be there. And it makes what Paulo said. So the capex getting expensive, and it depends on the country, and it depends on the feed-in tariffs or what the IRR is. So I think there is also some limits from the manufacturer side, physically. But the rated power turbines, of course, we have shown already the turbine generator can be 7.58 or 8 megawatt rated power. But mainly, I think 4 or 5 megawatts will be the next future. Yeah.
Also on the technological side we have seen some developments as well to be able to put wind turbines in low to medium wind resources sites. Is it a top priority, a medium priority? How do you see that in terms of technology evolution? Do you think it's just like a niche market, or it's something that you develop big time? Maybe we'll take the panel in the contrary order. Do you want to start?
I can continue. So, yeah, of course, I mean, all of us, we have to focus, also the investors or developers, they have to focus at first on the good windy sites. Of course, if there's not more existing, which I not believe, we have to just develop and make the acquisition on the right way so that we can find also the windy places. It's just a question of development. But of course, as I already mentioned, there is some low wind speed sites and there's a good wind speed size. So we have to also hold this production portfolio for all of the site conditions what we have. But I think the developers has to choose the right size. So because the wind conditions are actually the main issue or the most important thing in our business. And on the side, there is not only the wind conditions what we are focused on. Turbulences are also very big, also important thing for the lifetime of the turbine. Also the climate issues, like is it cold climate, normal climate, hot climate, turbine types. It's also because of the lifetime of the turbine, it's very important. Also the grid integration, smart grids, the grid integration to the smart grids, that the turbine is compliant to the smart grid systems is very important. There's a lot of issues actually. So the technology is means not only long blades and bigger turbines, etc. It's also the technology what's inside of the turbine, what we have to also continue. And because, as I said, as a company where we are mainly in 40 countries, so all of the countries have their different governmental permission system. In France it's totally different than in Turkey, everywhere. So that means we have big work, a lot of work to do, so to confirm the turbines for each countries. And it's not easy. So that's why all the investors are expecting every year new turbine type, bigger turbines, but it should be reliable. That's what I want to say at the end. Because it's not only one country or it's not only one turbine type, we are trying to produce for all the countries worldwide and for all the specific sites too.
I guess your question is related, well, we have class 1A sites and then low winds, and what happens in the middle. My company, Gamesa, once we launch a product, for instance, the 114, we launch class 2, in this case is 2.5, and class 3, 2.0. But I am sure that my colleagues will agree on the fact that more and more we see that there are not pure classes. And when I say not pure classes, is that the wind sites at the end, they don't fit purely in a class 3 with a perfect enveloping, etc. And what wind turbine manufacturers we are doing more and more is to sit and of course warranty the 20 years life design, sit wind turbines class 3 in class 2 sites. Why I'm saying this? Because I insist on the fact that the classes are a perfect envelope that sometimes, or most of the times, they are not fitting to the real wind sites. So for that purpose, we made an exhaustive analysis on the loads of every component of the class 3 wind turbines to introduce them in the class 2 wind sites. If there is any reinforcements to do or just any additional operation to do during the life extension, but at the end we warranty the 20 years life design. So maybe, yes, maybe your question is because you see more and more class 1A turbines and class 3A turbines, but what happens in the middle? And that could be an answer to the question.
I guess it's my turn now. What we see globally is a tendency that unless it's a completely new market getting into wind, the good sites are gone. So we will see more and more medium to low wind speed sites. And the ultimate goal is the same. Lower the cost of electricity means we have to increase the capacity factor on a given site. And you can do that by increasing hub height, increasing the rotor diameter, and doing a little bit on the rated power. So that's the engineering priority. Salespeople sometimes have time to market as another priority, which creates a conflict, but generally it's all about rotor diameter and capacity factor.
Okay, so basically everything has been said so much so far. With Nordex, I can also confirm that we have dedicated turbines for each individual wind class, starting from AC 3A, 6.5 meter per second average wind speed, up to IAC 1.A or 1A class to 10 meter average wind speed with a turbulence factor of 18%. So that gives a good base to go more deep into the project evaluation. Also with Nordex, we evaluate the fit of each turbine on specific sites where there's a purity of dedicated turbines to wind classes will break, and where we calculate and where we warrant turbines that are suitable for each individual project site. To ensure that we maximize the AEP and minimize the levelized cost of energy. In terms of the configuration, I think with Turkey we see a lot of AAC2A and 3A sites. As the market matures, the AAC1A sites will go away. May be revisit when talking about repowering in a decade or two from now. In any case, there might be other markets that open within the country, like in Germany, for instance, as an example, where with the new political goals, states like Bavaria are open up their sites and their forests for harvesting the wind, and for specific sites in the forest areas, the Nordex portfolio was adapted for higher hub heights in order to minimize the impact on the forest and to maximize the wind harvesting in higher hub heights. So there are not country-specific sites, but even within the country, we see individual sites and individual requirements in order to push the wind into the individual countries.
I'll open question to the floor. I mean, if you have some question more on technology, and then we'll go to another subject again. But does anybody of you has a question to ask? Please raise your hand. Yes, please. Can we have the microphone at the first row? Thank you.
Thank you. Arno van Wingener, Fraunhofer Institute for Wind Energy in Germany. First of all, one comment and then a question. Comment is to Andreas Bayer, like the sky is the limit, yeah, but you make your blades longer than 80, 90 meters and it's really going to hurt. So that would be a problem. I mean, not so much for onshore, of course, but offshore, that could be a limiting factor that I see. But the question I want to ask is that due to the enlargement of the capacity, even for the same capacity of wind turbine, the blades are getting longer. And Turkey has this wonderful landscape with all kinds of picturesque mountains, and it must be a hassle to get your blades through there. I mean, it can happen in Bavaria already, but in Turkey things could get even more challenging. Are you guys thinking of new solutions such as sectional blades? I mean, Enercon is doing this already, but it's only the inner 10 meters or so, and the top mass is interesting.
I may answer.
Well, sorry.
I'm sorry. Ladies first.
Thank you. Sorry. Yeah, this kind of solution. So as I mentioned before, since 2009, we have a 5 megawatt wind turbine. The size of the diameter of the rotor is 128 meters. So yeah, so we made section blades, but not only section blades. What we made at the end is to use the same transport that we were using for the 2.0 megawatt platform in terms of transportation and erection, and of course BOP. And when I say BOP, it's more civil works, platform, and roads. And yeah, at the end, well, that was our solution in 2009. We could transport, not exactly in Spain, as you know, we have a lot of mountains also. So yeah, there is a solution there. But at the end, we found solutions to transport the blades, because right now the bottleneck is the blade transportation, more than the height of the nacelle has been increased. So it will be an evolution, and Enercon has taken now the role to the section blades, as we did 7 years ago. But for the time being, we don't foresee to make this section for our new products for the time being. As my colleague said, evolution I've been 13 years in this sector, and evolution is amazing every 6 months.
That's what I wanted to say. In any case, we also see that the majority of those sites that we deliver our turbine blades to will have a challenge. However, we have a very capable and experienced logistic team that manage to transport even to the complex sites. To help construction work at the site, we have several means in order to minimize the necessary area for the setting up of the turbines. That includes for instance, single blade mounting and other means to really minimize the impact while the wind turbine or the wind parks are being set up. But also with the split blade Nordics for let's say short term, we will not introduce split blades, because analysis shows that not only reliability and let's say the critical splitting of a blade needs to be understood and fully managed, but also the additional cost needs to be absorbed by let's say yeah, by the levelized cost of energy, where this has been the key driving factors for us.
Thank you very much. Any other question? Yes, there's 2 questions there. If we can have the microphone.
Dolunay Güçlüer Küpeli. Borusan EMB.
I am from Borusan.
Ask you for the offshore wind central for Turkey. We don't have the licenses procedure yet, but for the future, do you have any study? And can you compare with the cost, investment cost, and the efficiency and the production about our country? I mean, for the Turkey specifically. Do you have any plan or RD study?
I mean, I would like to ask you also, do we need offshore in Turkey? Really? Do we have not enough place of onshore? This is the main question. At first, we have no feed-in tariffs for offshore. And it's 7.3, it's not, I think it's not enough. And also that our seas, I mean in Turkey, let's say, it's deep. So after 10, 20 or 30 meters, it's getting very deep. So the cost, especially for the foundation, and I mean, we know, I think, okay, I'm from Enercon and we have no offshore turbines. So maybe about the technology, about the cost, maybe GE can talk about more. But I think, not because we have no offshore, but I think for Turkey, offshore is not needed because we have enough place in Turkey. So, and there's enough wind. It should be only developed and planned on the right way. So that's why, and from the other side, the feed-in tariffs or the regulations are not there, because I think it's also not needed. That's why it's not really focused on that. And where we have worldwide the offshore projects, you can see it in the Northern Sea, or UK, or northern of Germany. You can see it in the Northern Sea. But I don't know if you've been there before, but I could see that the sea is very deep. So it's almost near shore or whatever, but it's not really offshore. So these are all the costs, and that I think why we have in Germany the offshore projects, because the square meter of Germany is just a half of Turkey, and they have 40 gigawatts in total.
Sorry, at least we'll have one subject of disagreement, because for the moment it was very consensual panel. But being a French national, actually we have the same thing in French. It's very, the sea is going very deep, and we do offshore. Okay, it's expensive. But maybe all the offshore suppliers can answer as well. I mean, do you see Turkey as a key? Yeah, I know GE is not making any offshore, but with the wedding with Alstom, it will.
Yeah, that's why I'm actually a bit surprised. We don't do any offshore turbines right now. So GE only sells onshore wind turbines. But to answer your question about the costs, the same studies I quoted when I was talking about onshore are also available for offshore, and it basically confirms what Arif said about Germany. So I mentioned that currently the LCOE for onshore is between 40 on an excellent and 100 euros per megawatt hour on a low wind speed side and a small wind farm. Offshore currently starts at about 100 to 110 euro per megawatt hour when the sea is flat, and it's an easy installation, so near shore, I would call it. When you really go offshore, and the German projects are probably the worst in the world, it goes up to 250 euros per megawatt hour. So unless you are prepared to explain to consumers why they should pay more for electricity, it doesn't make sense to start with offshore. That's our view. If there's a political will to promote renewable energy and the space is congested, like in Germany, then it might make sense to set offshore wind targets. But it's definitely, and it's going to remain, a more expensive renewable energy than anything else.
Thank you.
My name is Fatih Yıldırım. I am from Alpha Energy, chairman of board. My question is, do you have any technologies to avoid ice on the blades, or for avoidance, I mean, for de-icing technology. You know, this winter was very awful. Do you have any technology for that?
This extreme weather condition and icing on the blades, definitely. Please, Enercon.
Yeah. Yeah, as Enercon, I can say, luckily, that we have started with the icing system as first. So, in Turkey, we have, for example, a lot of projects where we have installed the icing system. Also in a lot of countries. I mean, that's a question of the humidity. I mean, if you have -7 degrees, there's no icing because there's no humidity. If you have between 0 and -4 degrees, the humidity is very high and you have the ice. And the problem is at first the safety, because ice can be thrown to outside, and on the other side is a balance of the generator because the different weights of the blades then because of ice. So that's why the turbines are stopping if icing is registered due to anemometers. So and we have developed the de-icing system. If the turbine stops, just the melting period, it's quicker or faster than a normal melting process, so that our turbines can start faster to produce electricity. And since a couple of years, we have developed this system again, that our customers can choose between running WEC and stopping WEC. So means the system can start before the icing is there, like anti-icing. So, and it starts, and that we have no ice on the blades. So the disadvantage of the system is okay, that we have internal usage of the electricity, but the advantage is the turbine is not stopping and is running, so it's also good for grid, and also you have no electricity losses, not so like in comparison to if you have no de-icing system. Of course, there's also some additional cost for that because the blade has to produce in different way. You have to build a channel in the inside of the blades, but we can calculate this from the wind mass and the number of the days or the hours in the year, how many icing days you are from the anemometers, from your wind measurements. So accordingly, we can propose to install the de-icing system or not. Actually, from my side,
I mean, ice detection or de-icing technology. Yeah, Nordex.
Yeah, so Nordex for quite many years now has an anti-icing system that is functioning like follows. We are heating up the surface of the turbines in the aerodynamic required areas. So that ensures that the relevant areas are covered, heated up, and the turbine has not to stop for a de-icing motion. This also ensures that the energy that we put in is being used in the most efficient way, because it's heating up a carbon mat right below the surface of the turbine blades. The systems have been installed in Northern Europe in many places, and they show during the relevant months of operation double-digit increase of AEP, not only because we are not having to shut down the turbine in order to put in the energy to de-ice the blades, but there is no stop necessary, because the blades, when icing may occur, the blades are being heated up to a certain temperature so that the aerodynamic architecture of the blade is still functioning. The second question that you have posed is in terms of the ice throw. That's a different topic. It's a topic of identifying ice on the blades in order to minimize hazardous situation when you're operating your turbine in a public area. Nordex is offering a blade ice detection system that measures the ice condition of each individual turbine rather than other systems that only uses meteorological scenarios, typically on the nacelle. We offer a system that has sensors in every turbine blade, measuring the frequency of the turbine blades while operating and ensuring that whenever the icing condition occurs, that the turbine will be shut down. In Germany, for instance, you have the need for a visual inspection after an icing event has occurred, the turbine has been shut down, to restart that turbine. With this system, it's been an online system that can also detect while the turbine is in idle mode whether the blades are iced or not iced, and can start automatically the turbine again without any operator interference. That has shown an increase of average energy production of more than 60% in the relevant months, because you are not always sure that you can visually identify ice on your blades while it's foggy, while it's during the night, so you lose energy production even though that the blades are not being iced because you don't have visual contact to the blades.
Maybe one last, let's say, common question for the panel, and then I'll go to individual question. What sort of new technology or improvement do you try to make on the turbines in order to improve acceptability? I'm thinking of definitely noise limitation, definitely, but also other subjects. I mean, is it something important for your company?
Me again? Okay. So acceptability has different factors, I would say. Acceptability can be influenced from the beginning of a wind park project, while the planning phase will include the locals. The local people will give the maximum of transparency during the wind planning phase. That is kind of out of the room for a turbine manufacturer, so there's no too much influence in this phase. We as turbine manufacturers can influence the physical features of the turbine in order to increase acceptability. Acceptability is, for instance, noise, for instance, shadow flicker, for instance, let's say visual impact when you're talking about touristic areas, but there also, this is pretty much on the planning phase. In terms of noise, the turbines are designed for the lowest noise emission, especially on IAC3 sites, on low wind sites, where the environmental noise is perceived as very low, so that the turbines, even though that they have low noise emissions, are standing out. Nordex is providing many different noise modes that supply or that enable the turbine to run in a very very efficient way, but fulfilling noise requirements. As an example, for instance, with our newest model, the N131 3000, we have established a standard noise mode of 104.5 decibel. This is a standard rating. There are noise modes even below that, down to 100 decibel. But with this 104.5 decibel mode, it means that in a distance of 1,000 meters, the people will hear that the sound pressure in 1,000 meters will only be 33 decibels. which is the acceptable limit. If you compare that to an industry standard in that area, where the average IEC3 turbines of all the manufacturers in average will have 106.5 decibel, that means that the Nordex turbines can be positioned 170 meters closer to the housing in order to achieve the same sound pressure than other turbines may have. And this gives the planning party much more flexibility in order to harvest their project sites, but this gives also more flexibility in order to fulfill even more stringent noise requirements.
Yeah, I think Andreas covered most of it. All the GE turbines can be purchased with noise-reduced operations as well, so that's pretty much standard. Noise is a major concern in all the heavily populated countries, particularly Central Europe. France is the same. So noise is a key issue for everybody, and besides that, there's not a lot the manufacturers can do. Andreas just mentioned shadow sensors, which are an option you can get from everybody, I think. Bat control, so taking care of bats who are living in that area, is another feature. But the basic acceptance can only be generated once the people living in a region of a wind farm are involved in a very early stage. What we see is, and we actively support that with financing solutions, is that the public community can participate in a wind farm, so that they not only share the burden of the existing wind turbines, but also the benefit from the revenues. So that's a non-technical means to basically increase the acceptance. But most of the acceptance has to be achieved during the planning phase of a project, not during the execution phase.
Just taking back to the question regarding noise, I think all manufacturers are concerned about noise. In some countries more than others, France in particular, you are concerned about low speed wind speed noise in particular. It's not just the 104, which is overall maximum power, nominal power, but in your case, it's because you have low wind, you have this kind of problematic that the wind turbine manufacturer will have also worked about. But I think your question should be more related to the local acceptance. I'm talking about the community. And manufacturers, in that sense, as my colleague of GE is saying, is the developer and the wind turbine manufacturer should jointly work from the very beginning. As manufacturers, we can create local jobs. We need to have warehouses. We need to have people with basic maintenance. To do that, we need security. So there are a lot of jobs to be created. A wind farm lasts 20 years. So this is an involvement that the developer and the manufacturer should have. And we know this very well because Gamesa has the brand Gamesa Energy. We are also developers. We have been developing in more than 20 countries. And this is something that if you don't do that, you're involved the community, let's say, in a percentage of your SPV, or you create jobs in the long term for the community, it will be a failure at the end, that's for sure.
Thank you.
Yeah, from technical part, like say noise, we have actually all the same system with operational modes, different operational modes to decrease the sound level. Also, you can use a sector-wise shutdown or sectoral management for the birds, bats, or for the shadow management. And also, we are using trailing edge system. Actually, I have not the possibility to present this, but if you can come to our booth. So
I did not know presentation, sorry about it.
I can show you the pictures what I mean with trailing edge system, because it's reducing, it's also developed by us, and it's reducing the noises a lot. And also, because of our philosophy, we are trying to use raw materials which can be used and recycled again, and like steel, coppers, aluminum, and try to use not so much plastics or whatever, but anyway there are no possibilities, sometimes like blades, etc., so that we have to use that. But the acceptance is also from the social way, like was Paula already said. Also the employment locally brings also the local acceptance to the people, and mainly that's the issue, that the people are accepting the wind energy turbines. Generally.
Okay. Brilliant. Okay, a very last question for each of you before we close. Maybe a first question for Nordex and Enercon, it should be the same one, is does the relationship between Turkey and Germany is a competitive advantage on the Turkish market?
I mean, we have to define the question actually. I mean, I'm original Turkish, but I growing up in Germany. It's the biggest advantage for Enercon, I think, because I know the both cultures. But as you know, in Germany there are a lot of Turkish people as well, and there's a big advantage socially between the two countries, and because in two countries the cultures are very well known, and it brings a lot of synergy with itself. But of course our R&D, research and development, is mainly in Germany, in our headquarters, but we are finding good ways to work together. And also from Turkey, our local colleagues have the opportunity to go to headquarters and learn and train themselves easily, and it's a good synergy between two countries, of course.
So it's basically a similar setup. We have a local organization here in Turkey with over 100 people, colleagues that are local, that are supporting the local communication. Our headquarters in Germany also mainly driven where the engineering department has its root. In any case, being supported and being in the communication with the local organization. I think to benefit from this combination, Turkey will benefit from the experience, I guess, that Germany has made globally or politically speaking with the Energiewende and maybe the pitfalls that came with it. And Germany will, in the midterm, benefit from the prosperous wind market in Turkey, to support and to supply their technology and their products.
Okay. So I think the other guys have their chances, actually, even if they're not German. Maybe a question for GE. There's a merging or wedding, let us say, to come with Alstom. And how will that change your strategy, in particular in offshore wind, but more generally, how will that affect and impact your global strategy for wind?
So first of all, I'll take the opportunity to answer the previous question, because although I'm a US company, representing a US company, the turbines are made in Germany, and one of the advantages of the relationship between the two countries hasn't been mentioned, which is the export financing coming from Hermes. So whether the units are built in Germany by one of the companies, there's export financing available, but I guess that's also available from Gamesa and the Spanish government. As far as the Alstom, the potential, I should say, Alstom acquisition is concerned, all I can say is that the current status is that about close to 30 different antitrust authorities are going through the approval process for this acquisition. It has been announced that the renewables business is going to be a self-sustaining tier 1 business, and it will comprise onshore wind, hydro, offshore wind, and a branch called New Energies. but we are not yet in a stage to talk about strategies. So until the closing can actually take place, the two companies act as a completely independent companies, and in fact, in some areas we are competitors, such as onshore wind. So the time to talk about strategies will come after the acquisition. Clearly, the main objective of this acquisition wasn't renewables, it was the thermal business, where we see a lot of benefits for our customers with the combined product portfolios. So renewables comes on top of that, but clearly the main driver is not the renewables business.
First competition and then strategy.
Yeah.
And for Gamesa, I mean, almost the same question, but it's your wedding, no? Joint venture with Areva on offshore. I mean, what will it bring in the near short term?
Well, the new joint venture is a company called Adwen, so it's in full operation since March this year. It's a company about 50-50 each company, 700 employees today. The headquarters will be in Spain, in the Basque Country, in Zamudio, but the factories will be in Germany, and we are going to respect the commitments regarding factories in France and UK that both companies had in the past. It was a natural joint venture as far as Areva has a huge experience in offshore and very relevant financial capacity with an industrial background. And Gamesa, we have the competences of engineering in wind sector and the manufacturing capacity. So I think the marriage was quite natural. We are proposing right now the both products that Areva and Gamesa we had in the past, which are 5 megawatts with different rotor size, 132 and 135. And we are already offering our new model 8 megawatts in offshore. That is a joint collaboration and engineering collaboration also.
It's no more competition, but
absolutely
still no merging.
Yeah, it is a running company. Let's say our strategic decisions and how we are going to proceed has been discussion for months and months before March this year.
Okay, thank you very much. Is there any question in the audience before we definitely close the session? No, you're very eager for coffee break.
Thank you very much.
Thank you very much indeed to all of you. Thank you to the panelists and thank you to the audience.
Ba-da-da-da-da-da-da-da-da-da.